So we are back with another 2.2 video. So if you haven't watched the first section of this, I highly recommend you go watch it, or else this might all be a little bit gibberish to you. We kind of just went over how our ratios can be used in a Cartesian plane. So how does x, y, and r all relate? And then we learned the cast rule. So now we're going to use this idea to figure out trig ratios of any angle. So let's look at our first example here. So write the trig ratios for angles in any quadrant. So our first example, the point P, -8 and 15, lies on the terminal arm of an angle in standard position. Determine the exact trig ratios for sine angle, cosine, and tan angle. Okay, so the first thing I'm going to do here is I'm just going to notate this as the standard angle here. So we are talking about the standard angles in these positions. Now, anytime you're given a point, so this is a coordinate point. Remember, coordinate points are x and then y values. It is telling us about this coordinate point here. So I'm going to draw my Cartesian plane. And now remember, this is x and this is y. This is negative x values over here, negative y values over here. And here we are at point -8 and 15. So that's going to be found in the second quadrant. So we got -8, +15. So roughly around right here is where our point is found. So again, in this trig unit, now that you've jumped into the -1 stream, you pretty much, anytime you're given a coordinate point in a trig question, you can create a terminal arm. So we are going to connect our terminal arm here. And remember, that is going to be notated as R. Now, at this point, you can drop down or create another arm found here. And now we have our right triangle. So you can see our right triangle is formed. So the angle in question is the standard angle that this point in a terminal arm forms, okay? So what does that mean? Remember, a standard angle is measured from the positive x-axis to your terminal arm. So there is our standard angle. So our question is to find sine of our standard angle, cos of our standard angle, and tan of our standard angle. Now, the reason we like to create a right triangle is because what we're actually going to reference to find these is the reference angle found here. So we're actually going to talk about the reference angle to reference and figure out the standard angle ratios. So let's note some values that we know about this. So remember, we're focusing on the fact that we have a right triangle here, which is very useful to us. So we can see our right triangle visually, and we actually know the length here. It's 15, it's our y coordinate. We know the length here, it's -8. And then our r value, well, we're gonna have to find that. So let's list all the things we know. That's usually your first step. X equals -8, y equals +15, and then the r value is in a question mark here. So something to note, on your data sheet, you should see something that looks like this. X squared plus y squared equals r squared. And that's because we're dealing with Pythagoras here. Notice, this would have to be hypotenuse, and then we can make this a and we can make this b. It doesn't really matter. But you have a squared plus b squared equals c squared. And remember, hypotenuse is always c. So that's how we formulate this equation because of our Pythagorean theorem. Now we can plug our values in. We know x is -8, we know y is 15. Let's solve for r. So x is -8, so -8 squared, plus 15 squared equals r squared. Now I would really recommend using your calculator to plug this in. So if I pull out a calculator here, I'm going to put brackets around my -8 and I'm going to square it. Recognize the square is outside the brackets. That's important because if you forget to put the brackets, you'll end up getting -64, but you should be getting +64. And then I'm going to do 15 squared. So that's 225 equals r squared. Now at this point, we're going to add our values together. So 64 plus 225. So that's 289 equaling r squared. And at this point, I'm going to square root. Okay, so this adds a little bit of trickiness to it. So at the moment, I'm just going to leave r to equal the square root of 289. Now, why is this a tricky thing? This is a tricky thing because what happens when you introduce a square root? So something to note over here. When you introduce square root symbols. So this is something you would learn in grade 10. But let's talk about having x squared equaling 4. If I decide to introduce a square root symbol, when you square root something and you're the one that brought the square root in, you have to take the positive and negative answer of it. So this will be positive or negative 2, because negative 2 squared equals 4, but so does 2 squared. That also equals 4. So we have to be wary of that, and it's really important in our trig unit. Why is that? Because technically right now, we have to be thinking about which quadrant our triangle exists in. If we were living down here, it might be negative, right? But you got to understand that r is always positive. So this is always positive no matter what quadrant you live in. Okay, so I'm going to say r equals root 289. Now if I plug that into my calculator, square root 289, I don't believe that that is a perfect square. Oh, it is, look at that. So I guess we will keep it as 17. If it wasn't a perfect square, then we'd be having another conversation about possibly simplifying it, but not putting it as a decimal. So now we have our x, y, and our r values. So at this point, you just have to remember that we are talking about the standard angle, but we're going to use the reference angles to figure out the ratio there. So on your data sheet, so hopefully you have your data sheet printed and beside you, remember that these are listed. Sine is y over r, cos is x over r, and tan is y over x. So you have all these values, so it's a matter of just now kind of plugging in your proper values. So our y value is 15, our r value is 17. So this will be 15 over 17. So my final answer here is sine angle equals 15 over 17. And then we will have our cos angle, which is, remember, we're going to use the reference angle in this case, and it's the x over r. And what is our x values? Our x is -8, our r value is 17. Okay, so this will be -8 over 17. So let's just write that out as our final solution. -8 over 17, we can circle that one off. And then finally, we are going to deal with tan. So tan and our standard angle, we're going to use the reference angle to figure this out. Tan is y over x, y is 15, x is -8. Now I'm going to clean that up a little bit. Usually you don't want your negative on the bottom if you don't have to have it. I'm just going to put it beside. So here, my reference angle, or sorry, my standard angle, tan ratio is -15 over 8. And there are your final solutions. Okay, so pause the video here, maybe rewatch it if you got lost anywhere, and if you're really confused, please just come in and ask some questions. But I'm going to move forward, and here's your check your understanding. All right, it's another example here. Why don't you pause the video, give this one a quick shot, see how you do, and then come back and watch. So hopefully you gave this one a shot. I'm not going to fully run through it, but I'm going to go through and quickly just highlight some things in the solution. So the solution's on the next page. So the first thing that they did here is you draw your quadrantal, hopefully that's what you did, and then you created your point and then your reference angle. So again, this would have been -5 here, and this would have been -12 here. And at that point, you can see that they noted the reference angle, but that entire blue angle here, that would have been your standard angle. And that's what you're really trying to find. You're trying to find these standard angle ratios. Some things to note here is as soon as you get started, start listing what you know. So we know that x equals -5, right? You know that y equals -12. And then r is your question mark. Now, even though that r lives in quadrant 3, we know that r is always positive. And at this point, you can go forward and solve for r using the fact that r squared equals x squared plus y squared. Again, you want to just memorize this formula, okay? It's Pythagoras theorem. Recall that this is your r value here. So they went ahead and found that r equaled 13. And then it was a matter of, remember, we have these listed on our formula sheet. We know that sine is y over r, so it's a matter of plugging in your y value with your r value. Okay, you can see that listed here. X over r, plug in my x value with my r value. So 5 over 13. Now some things to note is that both of these things are negative. And then 10 is positive, which works and makes sense because of our cast rule, C-A-S-T. Remember that 10 is only positive in the third quadrant. So that's kind of one way to maybe check if you're going in the right direction with these problems. Okay, so if you had any issues with understanding the solution there, please come in and ask some questions, but we're going to move forward here. So let's see another example. So suppose angle is an angle in standard position with terminal arm in quadrant 3, and cosangle is -3 over 4. What are the exact values of sine and tan? Okay, so as soon as you're told what one of the ratios equals, take note of that. This is talking about cos. And on your data sheet, cos is said to be x over r. So what the heck does that mean? Well, that means I know what my x value is and I know what my r value is. Notice there's a negative number there. Now recall with negative values on a fraction, -3 over 4, so maybe I'll move that negative a little bit up. Oop, I'll zoom in here. Recall that -3 over 4, that negative can either go on the top or the bottom. But, so does that mean that either x could be positive or r could be positive, or x could be negative and r could be negative? Which one is it? Well, recall what's special about r, that the fact that this is always positive. So that's really useful to know, because if r is always positive, then guess what? That means this negative symbol is actually this whole fraction is negative because of the fact that 3 is negative. So x has to equal -3. So if r is always positive, this means the x has to equal -3. Okay, so let's list this out. What do we know? We know x equals -3 and r equals 4. We don't know what the y value is right now. Now, this told us we live in quadrant 3, which is really, really useful because technically, since we don't know what y is, we could be in 2 different quadrants without that. So I'm going to put over here also, we know we exist in quadrant 3. We have to consider that. So here I have my -3 value, and then I'm going to draw my length here, or my terminal arm, and that will be a length of 4. Now recognize why knowing that you live in quadrant 3 is so important, because technically you could have drawn the exact same thing and said, well, this is 4 here, and then gone and solved for a different y value. Okay, it would just be the positive, but this doesn't work. So we're going to exit that out. This doesn't work because it's not in quadrant 3. So we got to live down here. So we're going to focus on this angle here first. And we need to figure out what this y value is. So this y value is a question mark. Now recognize our y value will be negative. And why is it negative? Because again, we're existing in quadrant 3 as our question states. Because in quadrant 3. So we can use our Pythagoras again. So let's find y. We're going to find y again by using x squared plus y squared equals r squared. And at this point, hopefully we know how to solve for this. I'm going to subtract x squared, and I will get y squared equaling r squared minus x squared. And I can square root both sides. And remember, when you square root, you can take either the positive or negative answer. In this case, I'm going to take the negative answer because I live in quadrant 3. So here, take negative answer because I live in quadrant 3. Okay. So now at this point, it's a matter of plugging in our values. So from our question, from that cos ratio, we figured out that r is 4, x is -3. So let's plug those in. So r is 4. 4 squared minus -3 squared. Just make sure that's all good. Yep. So now at this point, 4 squared is 16 minus -3 squared, which is 9. 16 minus 9, what will that give me? Well, let's quickly think about that. 16 minus 9 will give me 7. Yep. Oops. Let's get that out of here. Sorry about that. So that gives me 7. So y looks like it'll equal -√7. Okay. And I'm not going to put that into a decimal because I want exact values. So keep like this. Want exact solution. So want exact answers. So y equals -√7. So this here, this is -√7. And now finding our ratios of tan and cos will not be very hard. So, or sorry, sine and tan. So on your data sheet, we know that tan angle equals y over x. So in this case, our tan angle will equal our y value, which is -√7, over our x value, which is -3. And as you can see here, we can cancel out our negatives. So we get √7 over 3. And then, where do we go from here? Well, we ask ourselves, what is our sine ratio? So again, on your data sheet, you'll find that sine is y over r. So it's a matter of plugging in the correct values for y. So y is negative root 7. And then our r value, we were told, is 4. So there's your other solution there. And again, what ratios is this for? Or what angle in specific? The angle that we are focusing on is this angle here, the standard angle. Okay, so whenever you come up to a question, be really, really careful of where does my maybe first ratio exist? Does that tell me my x, y, or my r? Remember that r is always positive. And what quadrant do I live in? Because that quadrant, there might be two different types of answers depending on if they don't specify the quadrant. Okay, so if you have any questions, please let me know. This is kind of a your turn here. I would suggest giving this one a shot and then coming back and I'll walk through the solution with you. So let's go through the solution together for this question. So a few things you really want to keep in mind is quadrant 3 and that tan equals 1 over 5. So let's write that on the bottom here. Tan angle equals 1 over 5 and in quadrant 3. Now think about quadrant 3. Start by drawing a value right off the dot. Okay, this question's a little bit trickier than it might seem at first. So we live in quadrant 3, so we can kind of blank out all the other quadrants. Now what about quadrant 3 is special? The fact that we live in quadrant 3 is that tan is positive. But some things to note is that x is negative. And we also need to note that y is negative, right? All numbers here for x values are negative. All numbers here for y is negative. The reason tan is positive is because on your data sheet, you know that tan angle equals y over x. If y is negative and x is negative, they cancel out to become positive. So at this point, you can start extrapolating values that you need to know. So if this equals y and this equals x, we can say y equals 1. And we can also say x equals 5. Okay? But some things to note here again. We live in quadrant 3. The fact that we live in quadrant 3 means that my y value has to be negative, my x value has to be negative. So we're going to put negatives here because if we put negatives on here, that's the same thing. Negative 1 over negative 5 equals 1 over 5, right? So that's why we always have to be wary of what quadrants we live in. Now I'm already recognizing that they did mess up in this diagram here. So what did they mess up? Nothing too big here, just the fact that y has to be negative 1, so this is our negative 1 value here. And this is our negative y value here, because that's what our x value is. And now it's a matter of plugging in and maybe trying to find our other value. So we don't know what r is, and this being r, right there. And remember, r is always positive. So we're going to use Pythagoras. So here, they just plug in our values. So negative 5 and negative 1 into x and y. And they figure out that r equals positive or negative root 6. Why is there a positive and negative there? Because they introduced the square root symbol. So square root was introduced. So square root is introduced. Take both positive and negative. But you have to remember, r is always positive. So you're simply going to say, well, r equals root 26. Okay, so we're going to take the positive answer for that. And now it's a matter of going to your data sheet, looking at what does sine, cos equal. Sine is y over r. Our y value is negative 1. Our r value is root 26. So they will put negative root 26 here. So there's your first solution. Cos, on the other hand, is x over r. My x value is negative 5. My r value is root 6. So they plug it in, and there's your solution. So hopefully I was able to clarify any misunderstandings if you did look at the solution and you didn't understand it. You always got to walk yourself through some things here though. Remember that this diagram was written a little off. This should have been -5 and this should have been a -1. Always remember that r is positive, and consider the fact that x is negative in quadrant 3, y is negative in quadrant 3. So you might have to extrapolate that information with what you're given. So I'm going to stop the video here. Please go try out a few more questions that look like this, where you're given a ratio in your total quadrant you live in and you have to find the other ratios. In the next video here, I'm going to go through some quadrantal angle information and what the ratios are for these, because they are special. Okay, if you have any questions at this point, please come in and ask. Thanks.